My student ID is 1094992 from the course of COE101. Today, I would be explaining my part of binary classifier in my project Phase 2, me and Zaid Awadi, who's my colleague in my group of the COE101 project. As my colleague Zaid explained in his past video of the project, he explained that we did about what we did in the pictures of the three laptops and phones and watches, smartwatches, and he explained the purpose of our project and the purpose of the testing and the training of them. So in here I would be talking about the purpose and why we did that and what happened while doing everything. As you see in these numbers and all of these calculations, I would be explaining what we did in brief. So in this section, we developed and evaluated a machine learning model that could classify images as either laptops or non-laptops, in this case smartwatch and smartwatches. We trained the model using 114 images and tested it on 28 unseen images. The output of the classifier was compared to a human labeled data to assess its performance. Here's what happened. The classifier predicted whether each test image was a laptop or not, as you can see in here. A laptop and a laptop which holds P and N, which are in here. The classifier predicted whether each test image was a laptop or not, and it assigned a probability value PA representing the probability of the image being a laptop given the data. Then we recorded both the human label and the AI prediction for each test image, which is here, and this is the human one. Based on the comparison, we computed key metrics using standard binary classification terms. TP, which stands for true positives, when both the human and the AI agreed it was a laptop. TN, which stands for true negatives, when both agreed it was not a laptop. FP, which stands for false positive, when the AI wrongly said it's a laptop, while it's not. FN, which is false negative, which is this one, when the AI missed a laptop. From this, we calculated the recall sensitivity, which turned out to be 1, meaning the model caught all actual laptops, which is here, recall sensitivity. And we have as well as the specificity, true negative rate, also 1, showing it correctly rejected all non-laptops, which is here exactly. Accurate, perfect 100% on the test set, which is in here as well. This indicates the model performed exceptionally well, making no errors on the test images. It correctly identified every laptop and every smartwatch. Overall, this binary classifier demonstrates that our model can reliably distinguish between these two classes with high confidence. And this was our project about testing and training, and I explained all of this chart by our numbers that we got and by our and by our accuracy that we got at the end. And as I said before, the laptop stands for P and the non-laptop smartwatch stands for M in here. And the training pictures were 114 training and the tests were 28. And in total it was 142. And in here we can see the total of the training and testing. as 142 as we said, and the laptops was 71 in total, and non-laptops as well as 71. In training laptops, it was 57 pictures and non-laptops 57, and in testing 14 laptops and 14 non-laptops. And this is the data distribution of it, of the total training and testing of this diagram. So we made a data distribution chart of the numbers that we got. And that's all, and I hope you liked our project, and thank you for watching this one. Have a nice day.